Hi, welcome back. So in this video, we are going to discuss how to perform one-tailed t-student test for paired samples. So we're going to use the same dataset as in the previous video, but now our task is different. We have to analyze whether people attending therapy report a higher level of subjective well-being compared to people not attending therapy. And we assume that alpha is equal to 0.1. So in this case, you can go for right-tailed test and you can go for the left-tailed test. Because if people attending therapy report a higher level of well-being compared to those who do not, it's equivalent to saying that people who do not attend therapy report a lower level of subjective well-being compared to those who do. But let us concentrate on the right-tailed test. And first of all, let us start with designing the rejection region. So we have 8 degrees of freedom. Alpha is equal to 0.1. So our critical value is here. It's 1.397. Because we go specifically for the right-tailed test, our rejection region is everything to the right from 1.397. And now, when it comes to designing, computing test statistic, we assume that people who attend therapy report a higher level of subjective well-being. So when you perform two-tailed test, it does not really matter what you subtract from what, but in our case, we have to subtract mental health self-assessment before the therapy from mental health self-assessment after the therapy. So yeah, for instance, 9.3 minus 8.3 is equal to 1, so we calculate those differences in the same manner. We calculate the mean, the standard deviation of those differences, and we compute test statistic. Of course, its absolute value is the same as absolute value we computed before when we subtracted after from before, but in this case, it really matters, because what you assume to have a higher value should go first. Like, this is the rule. Also, it's kind of important when you assign the sequence for testing in Gretel, but we will get back to this in the next video. So we computed test statistic. When we look at the rejection region, you can definitely say that the null hypothesis should be rejected. When we analyze p-value, it's pretty low, it's like 0.001. So we can conclude that even if we assume a much lower value of alpha, we would still manage to reject the null hypothesis. And there is one more remark I want to make. So why should we use paired samples? Because if you do the same test for independent samples, so I did it in Gretel, so you forget that those people are the same people, just at two different points of time, and you assume that those are different, then you will end up with a much higher p-value. So if you remember, in our previous case, p-value for two-tailed test was below 0.002, and now p-value is equal to 0.09. So for independent samples, you can reject the null hypothesis only at 10% level of significance. But if you go for paired samples, you can reject the null hypothesis at 1% significance level. So this is the point, because as I mentioned before, using paired sample reduces variability. So consequently, it gives you much more freedom when it comes to data interpretation, because you can already forget about this. Those patients have the same age, gender, habits, genetics before and after the therapy. The only difference is the fact of attending the therapy. So, yeah, as I told you, it gives you much more freedom when interpreting the results. And it might happen that you might be unable to reject the null hypothesis when you use independent samples assumption instead for paired samples. So the conclusion is pretty straightforward. If you can use paired samples test, so samples are indeed paired, I mean those are the same people observed before and after the therapy, or those are the same stores analyzed in different geographical locations, and so on and so forth, then it's better to go for paired samples. Okay, so that was it when it comes to what I wanted to discuss in this video, and thank you for watching.